I think this issue is critical, that unless the engineering profession can attract more women and members from underrepresented groups, the profession will suffer in the long run. I believe the prediction of the demographics for 2050 say that this country will be 47% Caucasian. So whites will be a minority in this country. It's critical for the country that we get all segments of society, especially the Hispanic population, which is growing rapidly, and the black population, to have these young people come into engineering. That means we have to work very hard at getting them prepared, interested in it, and they'll be able to make great contributions. And for women in general as well. Well, the two dominant global problems now are pandemics, the spread of disease because of the mobility of people, and the impact of climate change. I think engineering is currently involved in addressing climate change and the diagnosis and treatment and prevention of the spread of diseases. So we need to do more. Engineers are basically responsible for the scale of vaccines for COVID-19. In terms of climate change, an activity is solar energy. Solar cells now are very prominent, especially in Florida, but around the world. The cost is coming down, the efficiencies are going up. Efficiency meaning what fraction of the light is turned into electricity. Engineering will play a big role in these two grand challenges. Young people should, number one, they should talk and listen to older people to find out what mistakes they made so they don't repeat them. My advice for careers is, I just talked to some students downstairs about this, is to not look too far ahead. That is, if you're in school, do the best you can in school. Don't look past school. When you graduate, look for that first job. And the important point here is that you should be ready for the opportunity. Work hard and play hard when you're young. And that's my recommendation to young people.
Essentially every major problem that we have requires engineering if we're going to solve it. Science and social science help us define the problems and describe the underlying solutions. But in the end, whether it's climate change or new technologies with computers, artificial intelligence, implementing all of this stuff all comes down to engineering. And what's so great about engineering as a discipline that a lot of people don't realize is that the marriage of science and engineering underneath it all is much more sophisticated and intimate than people realize. Engineers have deep understanding of science. Well, unfortunately, we're living in a world where the people who want to spread false information about scientific topics and things that relate to engineering have bigger megaphones than the people who are spreading the truth. And so we're really fighting uphill there. And that is unfortunate and scary, because when engineering comes up with a solution to a problem, we want people to actually use it. And if they don't trust the processes and the people involved because they've been told things that are false, and that really undermines our ability to help people with our advances. A lot of the people who can benefit from advances in engineering want to look to engineering and see themselves. And if they don't see themselves, then they're much less likely to trust the things that we come up with. And also, including everyone and giving everyone a fair opportunity is just the right thing to do. And so you want disciplines like engineering that we want to approve of to stand for the right things. And equity and inclusion are an incredibly important part of that, in not only in the United States, but around the world.
So Miami engineering faculty are very involved in addressing global challenge issues in a multitude of ways through research, first and foremost, working with doctoral students, master's students, and even undergraduates in cutting-edge research, which leads to creation of new knowledge and discoveries, innovations. In the college, we also changed the first-year curriculum to more of a general engineering education approach, and some of the classes there are exactly titled that. So we have a new class called Global Challenges Addressed by Engineering and Technology. The role of a university is to prepare the next generation, and these are the folks who will go into the workforce. So starting them early while we have them in school, in addition to teaching them the basic fundamentals and knowledge base, also the approaches that are needed to solve and tackle these problems. So one is just preparing them. The concept of lifelong learning is imparted very deeply into these students, so they can constantly learn. The other ways are by experiential outcomes. So as they're going through their educational programs, we also partner with industry who deal with some of these technology areas. We partner with the government through internship programs and so forth, which is also good. But bringing them onto campus really puts the spotlight on us and gives us tremendous amount of feedback to address these. So from the morning session today, we got some excellent feedback, excellent ideas, which many of us have already begun discussing even informally, and we'll be taking some of these forward.
In my career in both industry and government and now in academia, I have worked with leaders of all kinds, and I found that some of the most successful traits are that they listen. First of all, they listen to their people, their employees, they listen to their stakeholders, who could be their customers, they could be their suppliers if they're a company, so that they listen, but then they take decisive action, and that they put things together and they analyze what's working, what's not working, and they do this in a somewhat systematic way, and that's part of the work that I've done in dealing with executives at all levels, is to kind of teach them how to do this so that they're using some engineering tools and principles to analyze things, but that sometimes it's less about lots of numbers and more about getting everybody in the same room and saying, okay, this is what's working, this is not what's working, and then creating a vision for what do we want to be, where do we want to go. The key part is saying, okay, we're here, we know we want to be here, how do we get there, and what do we prioritize, and what needs to really be done to make this happen. Oftentimes, the things that people think are the answers when they come in the room are not it at all. And that's where, again, a good leader will listen and gather this information from all these different stakeholders, and then create the vision, and then carry it out and say, okay, here's what we have to do. Sometimes change is a verb, and so sometimes you have to enact change. If you make it more attractive to change than to stay where you're at, is the real key to doing it. So you try to, and so that you really help people to motivate to do things differently, to do things better. Engineering is such a broad field, and there's so many different parts of engineering. So some of the advice I would give young people is to try different things. And oftentimes someone that thinks that they want to be one kind of engineer as a freshman, they turn out to be something totally different as they go on. So I think if you can get work experience while you're in school, or whether it's actual for pay, whether it's an internship, whether it's a co-op, the more you can and try different things. And I know even personally, I started out in computer science and then later went on to industrial systems engineering because of the work I was doing. And I didn't discover this until I was after my bachelor's, and then trying some things like, oh wow, I really like this. And particularly if you want to be, if you're an entrepreneur, well now you really are going to be trying some things. And you need to be thinking about not just is it going to work technically, but are you're going to be able to sell it and make money doing it, so to speak, right? Or get somebody else to help fund you. So I think engineers need to be thinking more about the other things than just the technology, and think about taking some finance and business courses. Think more about the human side of engineering and what's going to motivate somebody to get excited about your product. And it's not always if we build it, they will come kind of a thing. You have to understand, well, what is the need out there? As engineers, we get caught up like, oh, this is such a cool thing. And maybe it is, but you have to be thinking much more broadly than that.
The pandemic has changed the science in my own field. I'm an aerosol scientist, and it certainly raised awareness in terms of this virus is in the air, and it's airborne, and it's transmitted in aerosols, which I happen to study. And so it's really transformed the people that work on the problem. It's brought together people from multiple communities, the medical field, the science field, the engineering fields. All of these fields are necessary to really work together to fight a pandemic. And so it's really started to bring, a lot of people together across disciplines to try and make a difference. So whether, for climate, there's a lot of anxiety, and whether being a scientist makes me have less anxiety, in some ways it does, because basically I feel like I can work towards relaying the science to the community. I can also work on solutions. I'm much more focused on solutions. We have to be. And so, a lot of the problems are, once we understand how things are happening, then we can move to educating the public and making a difference, because ultimately it's going to be the solutions are going to come from the choices that everyday people make. And so I think in that regard, I feel like I have control to be able to, transfer the information, the science to the public so that they will make better choices in the future going forward. For the advice I would give to kids that are interested in STEM and kids that aren't interested in STEM is the importance of STEM, to your everyday lives and understanding it. And science is fun, and everyone can do science in some way and understand it. And when you understand it, it just makes the world around you, much easier, honestly, to understand. So I just encourage kids, to try and understand as much as they can, to the level that they want to understand it, but they are the future. They are the ones that are going to have to solve many of the problems that we're leaving behind, unfortunately. And so I just encourage as many people, whether you think you are an expert at STEM or not, to learn the science, and so that you can actually help make a difference moving forward.